for the presentation. Okay, here we are talking about continuous and incontinuous intervals, and we are talking about improper integrals. Here, this is continuous. Why? Because x is defined in this interval from 1 to infinity. Okay, x is defined in this interval, so this is continuous, and we solve it as a limit problem. We put, instead of this infinity, we put a constant b, and we write b goes to infinity. And you see that it starts at 1 because it's discontinuous at 0. It's not defined at 0, okay? But it's defined in this interval, so we can have it as a limit problem. And the result is infinity. When we reach to a result infinity, we say that it diverges. Okay, so the next question. Here, it's continuous in this interval. Okay, it is continuous in this interval. It's defined, because e to the power 0 is 1. And it's defined, and we can solve it as a limit equation, and we can put the borders b and 0 here. Okay, in this part, this is a continuous equation, continuous function. Why? Because if we put 0 here, it becomes 1, and there is no other value here between this 0 and infinity, that this is not defined. It is defined in this interval, so it is continuous. Okay, you can see from the graph it is continuous even from the 0. When x is 0, it is 1. Okay, and it is continuous in this interval, and this graph goes to infinity. So we can solve it as a limit problem here. Okay, and limit integral of this one is arctangent and x, and we put borders. This one, okay, so this has two parts, to infinity. Both of the borders are, this is minus infinity, this is positive infinity. You can see it, this is minus infinity here, okay? You can see this is minus infinity, and this is positive infinity, okay? This part, so we divide this equation into these two parts, and we solve it like that. So we divide it into two parts and solve it as a limit equation. So here we say we start from b, any variable b, okay, a border, a lower border b until 0. So here this, so first of all we divide this, then we come to here. Here, what we had, 0 and minus infinity, and here 0 positive infinity. So we divide this into two parts, okay, from here to minus infinity, from 0 to positive infinity, into two parts. Okay, and the first part we solve it as a limit equation. As you can see, we put minus infinity, instead of minus infinity we put a b, okay, and we solve it. And in this part, what we do, instead of positive infinity we put a b, and we solve it. And here we take the limits, and again this arctangent e of x here, and arctangent e of x, and we take b 0, and we find the result. So when it is from minus infinity to plus infinity, we divide it into two parts, and we solve it like that. This is the idea, two parts, and we solve it as a limit equation. Okay, so and what else we did, we told about being continuous and not continuous. We say that, okay, 1 over 0 is not defined, and here when x is 2, our function is not defined, so it's not continuous. Being not defined is being not continuous. Okay, so here this is continuous because this x squared always positive, and square root is defined here. It cannot be okay, so this is positive, but maybe here if we have x as 0, okay, but at the bottom, let us say that this equation y is 1 or 2, because both of them, if both of them is 0, then this becomes continuous, but this becomes not a good question then. So let us say let y not be 0, be 0. Okay, so here this one, this is minus 1, so this is minus 1. If it is minus 1, then it's discontinuous because it becomes 1 or 0. So we can say that it is continuous from, we put it as an open bracket, meaning that it's not included. This means that minus 1 is not included. It makes this part discontinuous. So we put this bracket, means it's included. And infinity is always an open bracket. It cannot be a closed bracket. It's always an open bracket because we don't know where infinity is restricted. Okay, so my presentation, I